And welcome, Mindsetters, to this session of Learn Extra Live. I hope you guys are ready. You've got your pens, pads out, and you're going to make some notes. I'm Ty, and I've got Haley here in today who's going to be taking us for the session.
Hi,
What are we doing?
Ty.
I'm good, and you? How are
I'm
you?
good, thank you.
Where are my manners?
Um,
What are we doing today?
Today we're going to carry on with data handling.
Okay.
But I'm so excited because you know the numbers that we've been dealing with every single week that I've been asking you for the numbers, I'm going to be using that as data
Finally!
handling.
Okay. Because I'm always like put on the spot, like, so what are our numbers? But yes, we have the numbers. so-
Finally, we're going to be using them. Yay! I'm excited about that.
Okay,
I'm
so
going to go there.
while you go there,
Thank you.
Mindsetters, you know the drill by now. You need to get on the page, you know the link, www.facebook.com/learn extra. Talk to me. Let me know what you guys are thinking. If you're lost anywhere, if you need help, post on the page. That's the best way to help yourselves out. So Mindsetters, this is my advice to you. And you know today is probably the last day for you grade 10, so make sure you get those questions in. But for now, we've got a session to do. So Haley, take it away.
Thanks, Ty. Okay, grade 10's right. So the first thing I'm going to do is I'm going to put Ty on the spot again, and I'm going to ask him for our numbers. But before we do that, so no, this was last week. Okay, so this was actually last week. So we had last week. Last week we had 20,028. Ty, what are our numbers today?
We've got 20,775.
Hey, 20,700.
So close.
We are. I hope we've got some nice ideas about this, how we're going to celebrate this 21,000.
Yeah, I think we've
So-
got some plans.
Got
We've
some plans.
plans.
I'm great. I hope I'm included in these plans. Because remember, I missed out on the 10,000.
I'll have to talk to my
Okay.
people
Yeah.
to talk to your people.
Absolutely. Please do. Okay, guys. Before I start with data handling, what I actually want to do is I want to look at our percentage change, because this is quite a nice calculation. And the whole year I've basically been thinking I need to do a percentage change. But now, so this is a quick revision before we start anything else. So we are going to look at these numbers and we're going to say, well, what is our percentage change? Or in this case, we've got an increase. So what is our percentage increase? Now, what we do with this is that we take our new number, we minus our old number. So we basically take the change. So I'm going to do this. I'm going to take my new number, which is this week's, 20,775. I'm going to minus the old number, which was 20,028. And I want to know the change from the original. Okay, so my original was my old number. I always say to my kids, I'm going to write it now. I always say to my kids, you can think about it as kind of like your new minus old divided by old, and then it's a percentage, so we need to times by 100. So you can think about it, the formula that way. Very often you're given this formula. And let's go back to my purple pen. I want the percentage change, so that I need to times by 100. Now let's get our calculator out. Here's our calculator. So we had 20,775 minus 20,028. And we get an answer. We increased by 747 people. That's quite good, Ty, when you look at it like that. 747. Now we're going to take that number and divide it by the original, which was 20,028, and get an answer. We times that by 100 and see that our percentage change was, we just want to do that again, what it was 20,775 minus 20,028, right, divide by 20,028 and times by 100. So our percentage change was 3.7%. So our answer to that was 3.7%. Now that is quite a huge increase. If you think that we had 20,000 people and we went up by like 700, we increased by nearly 4%, which is great. Let's move on to my data handling. So what we have is, question 1. The table below shows the likes we have recorded every Thursday since the 16th of February this year for each term. Now, we started on the 16th of Feb to record the data. We actually started teaching a little bit before that. So it took us a while to start recording the data. And I've split this up into terms. So we see our first one, we had 6, 1, 8, 9. And then every week, it went up. We got term 1. Then I go to term 2. This is term 2, and you can see each one has got a number related to it. So for example, the 25th of May was 10,700. In fact, let's go back. The 17th of May was when we had our huge 10,000 party that I missed. And then we went to term 3, and we can see every day from term 3, and we finally got to, in the holidays, I think we got to our 20,000. So the 11th of October, that was the beginning of term 4, we got that amount. Now, with the kind of question like that, what they could say to you is how many likes were there on a specific day, what was the difference between 2 days. So let's see what kind of questions I've come up with. The first question says, what can you tell about the number of likes from the table? And it's quite a broad, open question. So what can we tell? We can tell that it is going up steadily. It is increasing. We can tell that it starts off at it starts off where we recorded, the first time we recorded it was 6,189. And then finally to today's date where we've got 20,775. And we've kind of got a constant increase. There wasn't 1 week where we had a decrease, where I don't know, can you lose likes?
You can, but we have retained everybody.
We have retained
so
every like.
we've
So,
been doing a great job.
So there you go. Okay, we haven't gone down. We've increased kind of at the same, roughly the same amount every week. So that's what we can tell from the graph. We can even tell what happens in the holidays. So if we look, for example, at the end of term 2, and the beginning of term 3, we can see that even in the holidays, we are getting likes on our page, which is great. And we'll discuss that a little bit later in the show. So let's move on to the next question. What we now have is that John took this data, and he drew a graph for the data, and we call this graph 1. So John's graph is a straight line graph. He has taken the number of likes on the y-axis, and he's taken the weeks, and he's done it by month, so the 16th of Feb, the 16th of March, on the x-axis, and that's the dates. And then you can see he's given us a dot, or a little square, for every week, and he's connected the dots. We've got gaps, and we're going to discuss them in a moment. So, why are there gaps in the line represented? So why are there gaps? There's a gap, and there's a gap, and there's a gap. And the reason there are gaps here is that we have term 1. We don't know what happened in the holiday because we didn't record it every single week. So we had a gap for term 1 holidays. And then there was term 2. So we can actually, let us label this. So tell you what, let's take a green pen, and this is term 1. And then we got term 2, holiday, term 3, holiday, and then the start here of term 4, where we've only had 2 weeks. So that's why there are gaps in the graph. Now, Lindsay drew a different graph of the data, and this is shown in graph 2. So let's have a look at Lindsay's graph. We've also got the number of likes, exactly the same on the y-axis. She's got the same months on and dates on the x-axis. But her graph is these line graph, lines going down, which actually represent kind of like a bar graph. So she has created them. We also have gaps. Okay, let's change that color so we don't get confused with the graph. Okay, but we still have a gap. We have 3 gaps for our 3 school holidays that we've had. So in other words, this is term 1, this is term 2, this is term 3, and finally term 4. Okay. We can see that it's increasing. It looks like it's increasing pretty much the same as John's graph if we had to connect those, but they're not connected. So let's read our questions. Is this a bar graph or a histogram? If we can see through the lines, like in this case I can see through, then it is a bar graph. So this is a bar graph. Should it be a bar graph or a histogram? Now the question is, what is the difference between the two? A bar graph is when you have data that does not follow on. A histogram is when you have data that is continuous. So this seems to be continuous because I'm talking about every Thursday. And I'm talking about weeks, and I can't change the order of this. I always say to my kids, if you can change the order around, then
there's probably something
you should
wrong.
be a bar graph. But in this case, I'm going from Thursday to Thursday. I don't know from the graph or from the table what happens in between.
So if you're shifting
So
it
I
wrong.
can't make it a continuous line. I know that from 1 week to the next. Let's go back to my table. Go back from the table. So I know from 1 week to the next, let's take these 2 weeks. I know that it goes from 6351 to 6578. But I don't know how it actually changes in between. I mean, maybe it increases huge on a Friday or a Monday. So I can connect these lines. So I can't really connect these lines. And that's why it's not continuous. We call it discrete information. So let's go back to that. So it is a bar graph. Has Lindsay selected the correct graph to draw? Yes, she has. So she has because it is discrete information. So she has created the perfect graph. Who has the better graph, John or Lindsay? And explain your answer. Well, in this case, I'm going to go with Lindsay. She has a perfect graph. She's used a bar graph because it's discrete information. She's given us gaps and spaces, and it is perfect. John's graph, although not a bad graph, is a line graph, but in reality, he should not have connected these lines. It should have been a broken line graph. So, but now having said that, I want you to be careful of this fact because very often we see graphs that should be broken line and they're actually in fact not, they're solid lines. So John's graph is showing us more a trend. It's showing us what's happening, and we can see that is a constant increase. But it should have been, there should have been little spaces in between. It should not have been connected in a straight line. And that's the only reason I'm going to say I think I prefer Lindsay's graph. Let's see if we've got any more. Okay, who's the better graph? I'm going to go with Lindsay. And you can explain the reason. Right, let's move on. Now we've got Indiana decided to draw us another graph. So she wants to show how the number of likes increased each week during each term. She calculates the increase, which is similar to what we did at the beginning of the show, in likes by subtracting the number in week 1 from the number in week 2, and so on. So she takes a higher number minus lower, work out how many likes increase we had per week. And then she drew a line graph. So we've got an increase in likes, and in this case we only go up to 800. Well, in fact, what did we say today? No, today was less than 800. It was close.
It was 7
something. So she's got maximum of 800. We've got anywhere from 0 to 800. She's given us the weeks of the term. And in this case, what she's done, she's given a weekly increase of Facebook likes. She has drawn 4 graphs on the same set of axes. And she's color-coded them. So we've got term 1, which is blue. Term 2 is red. Term 3 is green. And term 4 is this blue line with a yellow dot in it, yellow square. I'm getting my dots and my squares mixed up today. Question 1 says, why does the blue line only start at the 5th week? So, good question. Why does the blue line only start at the 5th week? Which line is the blue line? The blue line is term 1. So this is actually term 1. And why did we start in the 5th week? Do you remember at the beginning of the show I said to you, we've got the information from the certain date. I'm going to go back to these tables. We started recording on the 16th of February. So we only recorded on the 4th week. And therefore we could only have our increase from the 4th to the 5th week. So on my graph, I could only record the 5th week because I didn't record the starter earlier. Let's go back to Indy's graphs and see what the next question is. So, okay, let's add that question. So why does the blue line, we only recorded from week 4. So I can't start my graph earlier because I don't know what happened before then. From the graph, when was the biggest increase per week? So from our graph, we look at the biggest increase. Well, our biggest increase is actually in term 1, okay? This blue line, that's our biggest increase, term 1 between the 6th and 7th week. So our biggest increase was term 1 between the 6th and 7th week. We can also look at this per term. So where was our biggest increase in the other terms? So maybe in term 2, let's look at term 2. It was between the 3rd and the 4th week of term 2. In term 3, we've got our biggest increase between the 6th and the 7th week. And in term 4, well, we've kind of got the biggest increase this week. So, question is, can you explain why these large increases occurred? What we need to do is we need to think about our terms. So, I want to go back to term 1 and see where that is in our graph. So I think, I'm sure I've got enough time to just do this part of the question. But it's between, okay, the 6th and, so term 1, I'm probably going to guess that there's some tests going on in term 1 between the 6th and the 7th. You know, we've kind of done enough teaching. I think also probably word of mouth. What is interesting for me was our term 2 increase. And our term 2 increase was between the 3rd and 4th week. So we had, I'm just going to number these. So this was the this would be the 2nd, and that would be the 3rd, and that would be the 4th. Our big increase was going into the 4th week. And that was because we were all pushing so hard to get us to 10,000. So that part of the graph, go back to our graph. That part of the graph here is our push to get to 10,000. Isn't it so wonderful when you can actually see it?
It's awesome, because then the likes really spike that day.
They really spike that day. And then there's this one in term 3 where we've got our increase. We're coming up to exams, maybe.
That's always, yeah.
Definitely. Term 2, definitely. We've got exams coming up. So tests and all things. So, but I think on that note, let's take a bit of a break.
All right.
So, yeah.
So mindsetters, breaks my heart. We thought we were going to hit 21 by today, but we still can, but we need your help. You need to tell your friends to tell their friends to get on the page and keep on liking. Like some more, and tell their friends to tell their friends to like some more. But for now, we're going to take a quick ad break, but make sure you come back and you have your pens, pads out, and ready to make some more notes. See you soon. And welcome back, Mindsetters. We had a nice little break there. Now you're back, you're ready. You've changed out of your uniform, whatever you had to do. I know you only had 2 minutes, but hey, it's 2 minutes. Come on. You could be faster than that. But anyway, Mindsetters, keep on getting on the page. Keep letting me know what you guys are thinking. If you're lost and if you need help, or if you just want to say hi, go ahead on the page. We actually had one of our Mindsetters, Tivato, who wanted to find out, in the line graph that John drew, if he connected all the boxes without leaving spaces, would it be wrong?
Okay, it wouldn't be wrong. You mean the spaces that we left in the middle? It wouldn't be wrong if John was just showing a trend, because in actual fact, from this point to this point, it does increase. During the holidays, it did increase. So I'm going to say it's not wrong. It should really rather have been a like a broken line graph, and that's why John left the spaces. And he also left the spaces because he wanted us to actually bring our attention to the fact that the data had a gap. The data had time gap because we didn't record during the holidays. So wrong is a hard word to say. I'm going to go with maybe not 100% correct.
Yeah,
makes sense.
You said it's a gray area.
It's a bit of a grey area. Okay, let us move on to the next question. Right, so we've organised in these graphs and we've decided, wow, we've got our increases, and I love this increase in term 2. And I think the last question was actually, there was a large increase in the 4th week. Why did this happen? I answered that before the question. Let's move on to the next question. Right, Indiana wants to find out more about what happened in each of the holidays, which is really nice. Use the data in the table below to work out the mean, the average increase per week for each of the holidays. So now in our holiday between term 1 and term 2, we had Easter revision. So luckily, you were all still liking our page. So the end of term 1, we had 8,144 likes, and then at the beginning of term 2, we had 8,918. And this holiday was 4 weeks. Then we went on to the next holiday between term 2 and 3. We had winter school, and we had an increased 5-week holiday there. And finally, spring school between term 2 and term 3, where we had 2 weeks. So I've got these separated. So let's do this. We want to know the average larks per week. So in our Easter revision, what we're going to do is we're going to work out the difference between those two numbers. So we're going to take our 8918 and we're going to minus 8144. We're going to get how many larks occurred in those 4 weeks. So let's get our calculator out, and we've got 8918 minus 8144, and we get an answer of 774. So we've got 774. But the question said the average per week. Now we're going to assume that we had 4 full weeks. We're going to assume it was the same amount. Well, we're looking at the average per week, so we're dividing by 4. Remember, our average is our total amount divided by how many we had. So 774 divided by 4. So our calculator, let's divide it by 4, and we get an average of 193.5. So that's 193.5 larks. Now, this is another one of those little bit of gray areas, because we can't really have 193.5 larks. It can either be 194 or 193. In statistics, though, we usually can deal with half a person. Like, you know, the average birth rate is 2.1 children per family or something.
I find always
Two.
weird. Like,
So
there's a 0.1?
statistically, when we're dealing with lots and lots of values, we can. But what is a nice thing for you to do is write that number in, like you've calculated it. And then what you can say is, well, okay, in actual fact, I need that to be 194 larks, because I can't have half a lark. So what we do in that case is that give both answers, because if your teacher's looking for the fraction, then you've got the fraction, and if she's looking for a whole number, you've got the whole number, so kind of give both. Yeah, the 2.7 always fascinates me.
Like, there's
2.7
0.7 kids? Weird.
But like I said, statistically we can have a fraction. Yeah, let's do the same thing for winter school. So we're going to take the 2 and we're going to minus. I'm going to move my calculator over a little. No, it's too much. I'm going to move my calculator to the other side. Right, and I'm going to say 13623 minus 12104. And I get an answer of 1519. And now I've got 5 weeks for that. So I'm going to divide by 5. And I get an answer of 303.8. So in this case, 303.8. And again, we can round it to 304 larks. So you can see that it increased quite a bit, which is quite nice to see, from spring school to winter school. And lastly, let's do spring school. And in this case, let's get our calculator out. Move our calculator back here. Do the same thing. We've got 20,028 minus 18,404. And we get an answer of 1628. And there are only 2 weeks divided by 2. And I've got 812 on average. So the interesting fact for that is 812. So let's write the answer in first. 812 on average. Can we think of a reason why our spring school was so popular? Well, in actual fact, I think there's 2 reasons for this. One, we're getting towards the end of the year, and especially our matrics are now worried. They've had prelims, they're getting ready for finals, and there are a lot more matrics that are liking our page. And the other thing is I think, Ty, that I'm going to put my head out there and say it's probably word of mouth. Because I think you nag them enough to say, tell your friends to tell your friends to tell your friends, that I think we've actually got word of mouth. And now if you think we've got a bigger community, so if just every person, we've now got 20,000, if every person just tells one person to like, then we can double our community. So word of mouth is working, I think, quite well. So our increases hopefully will get a whole lot better.
Yeah, I hope so too. Like,
So-
it's always fun. Always fun on the page.
Absolutely. Absolutely fine. And I think that takes us to the end of the questions that I have on the numbers. So I'm really glad that I was actually able to use them. Let's move on to some other questions about data handling. So the question number 3 says, the age in years of patients treated for malaria at 2 different clinics during a certain month was recorded as follows. So we got Clinic A, where we've got 5, 7, 18, 24 carrying on up to 63. And Clinic B, where we've got 37, 28, 17. Now, the one thing I always look for when I see data and when I see numbers is it in order? That's the first thing that kind of like pops into my head. And I say, is it in order? So Clinic A, I can see, is actually going up. So it is perfectly in order. And Clinic B, I know, I make a note next to it that I'm going to have to reorder this. What is the median for both clinics? So there you go, my first question. Median. Remember, your median is your middle number. So we are looking for the middle number, and it must be in order. Has to be in order. Very, very important. Kind of underline it, highlight it. So we first have to put them into order. Now, Clinic A was easy because it's already been done in order. So Clinic A, I can just answer straight away. And what I'm going to do in this case is I'm going to take a color and I'm going to cross off as we go. So I'm going to cross off one from the top and the bottom, and I'm going to cross off the second one and cross off the third, and I'm going to end up with 2 numbers in the middle. So my number has to be between those 2 numbers. I always draw a line kind of in the middle of it, but I think my line's too long, so let's just delete that. Right, so the median is between 24 and 32. So let's go back to, we've got between, yeah, I've lost a pen, between 24 and 32. So the way I do this is I add them up and divide by 2. But don't forget your BODMAS. Really, really important, crucial stage that we have a BODMAS here, because we have to, on our calculator, say 24 plus 32 equals that, because I want my adding first. And then I divide by 2. And I see that it is 28. So my median here was 28. And remember, we've always got a reference. And what are we dealing with? This is years, so 28 years. Right. Clinic B, on the other hand, I need to put into order. So I have a look at the values, and I can do this in a number of different ways. I can look at my values and see which ones are the smallest and put them into order. I can use a stem and leaf graph. So there's a whole lot of things. I'm just going to do this by observation. So have I look at the values, and I'm looking for my teens. So my first one is 17. Okay, and then I cross it out so I don't get confused by it. Then I'm looking for 20s, and I can see that I've got 26. Cross that out, and I've got another one of 28. Don't forget, you need to write in every number. Even if they're duplicated, then you just need to carry on recording them. Right, then I go to my 30s. I think I've finished my 20s. I've got 37, 35 is my next number. 35, 37, 39, and then I go up to my 40s, so I've got 40, cross that out, 43, and 55 and 56. Write them underneath here, 55 and 56. What I always do once I've done that is I count my values, just to double check that I haven't left any out. So I've got 2, 4, 6, 8, 10 values, and what did I start with? 2, 4, 6, 8, 10. So I know that I've got the correct number. And then I take my different color, let's take green this time, and I'm going to do the same thing. I'm going to cross them out and go down. So crossing either side. And I see that I'm left with my 2 numbers, and it's between these 2 numbers. So Clinic B was 37 plus 39, and we're going to divide that by 2. And on my calculator, don't forget BODMAS, so we've got 37 plus 39, and then divided by 2, and I get the answer of 38. Now, also make sense of your answer. Make sense. Is it between the 2 numbers? Because if I get an answer that is not between 37 and 39, I know I've made a mistake. Or in this case, between 24 and 32. So just be careful that it is in between. And if it's not, you haven't used BODMAS. What is the mode of Clinic A? So we're going to Clinic A, and we need to find our modal class is the one that occurs the most. So we go through our numbers and we see that I've got 24 that's been duplicated, and it is the only one that occurs twice. So my mode is 24. And they only asked us for Clinic A. Perfect. Calculate the range of both clinics. The range, what is our range? Our range is our highest minus the lowest. So we're going to do each clinic. So let's do Clinic A. We'll do in purple. Our range in this case was easy to work out because we had 63 was our highest, minus our lowest was 5. Okay, I think I left out the 5. If I go back to our first calculation, I left out the 5 there. How interesting is that? I think let's go back to do our median for Clinic 5.
This is why it's always good to
Good to check. Good to check. I was hoping somebody picked that up. Let's do our median again. I was wondering why that should work like that. Okay, so our median, in fact, for Clinic A, we're going to delete that. If we had missed that 5, would be fine. So let's do that again. Right, cross out the 5 this time. 7. Aha, we ended up with one number. Our median, in actual fact, was 24. It was easier. Let's go back and calculate the rest. See, check as you go along.
Always good.
As you go along. So, 63 minus 5, and we get an answer for that. And that is 58. So it was 58. What color are we in? Purple. 58 years. And then for Clinic B, let's go to yellow. Clinic B, our highest, well, in this case, when we put them into order, we saw that our highest was 56. And our lowest, when we put them into order, was 17. So on our calculator again, 56 minus 17, and we get an answer of 39. So what we can tell from the range is that Clinic A has got a lot more younger but a lot older. So they've got a greater range of ages. Whereas Clinic B, they've only got 39 ages between the kind of lowest and the highest. I think maybe on this clinic note, I think it's time to take a bit of a break.
Yes, I think so too. Mindsetters, do not disappear. Like, that's just a bad idea, you know? I'm just thinking that's
Absolutely.
a horrible idea. So mindsetters, stick around, and don't forget, tell your friends to tell their friends to get on the page and like the page and join in. But for now, we'll see you after this break. And welcome back, Mindsetters. Hope you had a nice little break there. You didn't disappear too far from your TV, and you're there with your phone and your pads and your pens, so you can make sure that you're making notes. It's so, so important. I know you guys have exams coming up real soon. They're like just there, around the corner. So make sure you guys are here with us, paying attention, and sending in those questions. But for now, we have a session to still do. So, Haley, take it away.
Thanks, Ty. Okay, so when we finished, we had just done the ranged. Let's move on to the next part of the question. And this question says, calculate the mean for Clinic B. So our mean, just a quick revision of what mean is. Our mean is is basically what we talk about in every day. We talk about average. We add up all the values, add up everything, and divide by the number of values. So we're going to do that. And what I want to see, and especially it is normally out of 3 marks, I want you to show all your working. So add up. You can even tell the teacher that you're going to be doing 37 plus 28, which is not the most crucial part. What we need to see that total. So what I'm going to do is I'm going to get my calculator out, and we're going to probably have to do this in stages. So I'm going to do 37 plus, and check as you're going along that you're entering the correct number, plus 28, plus 17, plus 56, plus 43, plus 55, plus 39. So we're checking as we're going. Okay, 39 is the last one I did, plus 40, plus 26, plus 35. So I'm checking them all as I'm going. I've got 376. So I want you to show this total. I've got 376. And now I'm going to divide by how many values are there. I'm going to go back and remember I counted that there were 10. So it's 2, 4, 6, 8, 10. So there was 10. And what is it? My answer, my average is 37.6. And I'm going to leave it as a decimal, because again, I'm dealing with statistics and I can deal with a portion of a time. So I'm going to leave it as 37.6. Mean of Clinic B. And let's move on to the next part of the question. Oh, that was the end of the question. So let's move on to the next question then. Right. The table below shows the malaria cases and deaths reported in the Limpopo province during 2004. So I think this was a follow-on question. We're still dealing with malaria. Use the table to answer the questions that follow. We've got months of the year. You can see January, February, March. And I always like to analyze the table, make sure I make sense of the table. I've got the number of cases. So we're dealing with malaria. So in January, I had 272 malaria cases. And then I'm looking at the number of deaths related to those cases. So I've got 7. And it goes through the entire year. We've got a total here. So these are the total number of cases for the year. And clearly, I don't have the total number of deaths. But now, makes sense of the graph, makes sense of the table, then it's easier to answer the questions. So how many cases of malaria were reported in April 2004? So let's go back to April. Let's delete that. We're looking at April. So we find April. How many cases of malaria were reported? We've got 634. Right. Let's see the calculate the total number of deaths, F, as a result of malaria in 2004. So we're looking for this F value. And what am I going to do? I'm going to add up all the values in this case. So I'm going to say, and I know, especially dealing with small numbers, our instinct is to say, well, I can do this in my head. 7 plus 6 is 13, plus 6. But you guys have got a calculator. So don't assume you can do it in your head. Rather use your calculator. So I'm going to use the calculator. And I'm going to move it over here so I can actually see what I'm doing. And I'm going to say 7 plus 6 plus 6 plus 9 plus 5. Then I've got 0, 0, 0 plus 4. Okay. And then 2 plus 5 plus 6. And get an answer. I've got 50 total deaths. I think I need a color pen for that. So how many deaths did we have? We had a total of 50 deaths. Right, let's move on to the next question. 4.3 says, what is the range of the cases reported over the 12 months? So we're looking at the range being the highest minus the lowest. So I'm going to glance through my values and see which is the highest value. So I've got 696, which I think is probably the highest, but I carry on looking, that's lower, and carry on looking through all the values till I see 696 was in fact the highest. So what I suggest you do is actually highlight the one that you think, but carry on checking all the others. Now, which is the lowest? Well, the lowest I've got very low, 121's low, but then these are lower. So 35 in August seems to be the lowest. And all I need to do is get the 2 and say 1 minus the other. So I've got 696 minus 35, and we get on top 661. 661, and this is actually, these are cases. From 2004 to 2005, the total number of cases in Limpopo as a result of malaria decreased by 11.5%. Calculate the total number of cases in Limpopo during 2005, rounded off to the nearest whole number. So what are they telling us? They're basically saying that from 2004, we had a decrease of 11.5%. So let us work out what our total was in 2004 was 4899. So in 2004 we had 4899. 4899. And in 2005, we basically want to take that and we want to minus 11.5. Right, let's try write that again. We want to minus 11.5%. Board's doing its own thing today. It's making lines where
It's always hearing, it's hearing somewhere that, oh, we're wrapping up. So it's like, I'm going on holiday early. I'm like, no, we still have work to do.
we've still got lots of work to do. Absolutely. We're going to try to work out how we're going to do this one. So we need to take our noun and minus. But now remember, you cannot minus a percentage. Percentage, we need to multiply. So we can do this two ways. We can actually take our 4899 times by 11.5%, get our answer, I'm going to write it in as answer, and minus it. So in the next step, we're going to take our 4899 and we're going to minus our answer. I'm going to write it like that. I want to work that out for you, but I'm going to show you a quicker, easier way of doing it. So what we're going to do, let's take a different color pen. We are going to take our 4899 and we're going to times it, but we are actually going to decrease the percentage already. So we're going to take 100% minus 11. Let's try that again. 11, I'm not picking up the pen enough. 11.5%. So first I'm going to quickly calculate that. And it's 100 minus 11.5, and I get an answer of 88.5. So this is 88.5. So I'm going to take 4899, and I'm going to times it by 88.5%. And I'm going to show this to you in one step. So let's get our calculator out. And we've got our 4899 times by 88.5. Don't forget your percentage sign. And we get an answer of 4335.6. I'm going to keep that, 4335.6. And go back and reread the question, because I remember something. The question said, rounded off to the nearest whole number. So always go back and reread your question, because you'll pick up things like rounding off. Okay, so let's round that off to the nearest number, and that becomes 4336. How are things going on Facebook there? We got a lot of interaction today.
Yes, we have people posting like they do.
Like they do. I'm glad to hear. Okay, let's move on to the next part of the question. Right.
Everyone keeps harassing me about 21. I'm like, but we can't get there without your friends.
Absolutely. Randy, we need your friends. Okay. Calculate the case fatality rate in January 2004 using the formula. Now, in your maths exams, you're going to see formula that you might not have seen before, that might not have come up in class. But remember, don't be scared by a formula. Just analyze what the formula says and substitute values into the formula, and you should be able to get your answer. So don't be frightened by it. Our case fatality rate, which they've asked us for, is actually the number of deaths, which I know what that is, divided by the number of cases. And I know what that is. So I'm looking for January 2004. So we're looking there. My number of deaths was 7, and my number of cases was 272. So my case fatality rate was actually 7 over 272. And I can actually take my calculator out and now quite easily substitute that and get an answer of 0,025 or 0,03. So show all your working, show your substitution, and not that hard to do, even though you've never seen that equation. Write the ratio of cases to deaths for November in its simplest form. So we're going to find November. Let's change our color so we know what we're looking at. Okay, November was 5 and 560. We're looking for cases, so that was 560. And our deaths was 5. And now we need to simplify that. So the easiest way to simplify it is we know 5 goes into 560. So let's work out how many times. So we have 560 divided by 5, and we get 112. So I can simplify this as in 112 to 1. And that's in the simplest form. So perfect. And I've got the cases to death. So it's important that when you write out a ratio that you don't swap them around. Okay, next part of the question says, calculate the mean number of cases reported per month over the 12-month period. Round off your answer to the nearest whole number. So the mean, I'm going to add them all up. So I want my total. In fact, I've got my total. My total's been given to me. So I've got 4899. And how many months were there? I'm looking for the average per month. There were 12 months. So I've got 4899 divided by 12 is going to give me a mean of 408.25. And then it said to the nearest whole number. So in actual fact, in this case, it is 408. I always like to show every step of the working because I never know where the marker location is. So especially when it comes to rounding, before you round to a whole number, or even if you're rounding to 2 decimal places sometimes, write out the number that you have and then round off. So it just makes it a little bit easier. I want to see if there's another part of this question. No, we're moving on to the next part of the question. I actually think I'm going to leave the work here. I know I've still got some more time, but I don't think I've got time to do another whole question. What do you think, Ty?
I think, let's see, we probably have about another 2 minutes or so.
So I think I'd rather actually stop here and kind of do a little bit of
Recap.
revision and a bit of a recap.
Cool. That
So I
sounds like a
think
plan.
that's what I'm going to do. So I'm going to find a little bit of space. I know I've got about 2 more minutes. So we've been dealing with data handling. What's important about data handling? Analyze the data. Remember last week we did the whole show. You were with me last week. We did the whole show where we were looking at the surveys and we were looking at questions that they were asked. Today we've basically been dealing with analyzing. So the most important thing to remember when analyzing the information that we got is being able to read off the graph, which I'm sure by now that you can do. So the most important thing we needed to look at was our mean. Remember, was when we add up all the numbers and divide by the number, we have the median and the mode. And I just want to actually discuss these 3 central tendencies. We call them central tendencies. So when we look at data, we normally look at the mean of it. We would look at the median and we look at the mode the most often. Now, they each have a different kind of place and a different. We talk about average in real life, we talk about mean. But every now and again, our median is the one that we should be looking at. So the important thing about the median is that's the middle number, and we've got as many low as we do high. And what is nice about the median is that it excludes any what we call outliers. And what is an outlier, you might ask? Well, I hope you don't, because I hope you've done it in class. But very, very big numbers or very, very small numbers, it excludes those. So we're looking at the middle value. The mean includes all of those, and sometimes those outliers, especially if they're very, very big, can skew the mean and make it a little bit higher. So just have a look for outliers. And on that note, I think I'm going to have to say goodbye and hand over to Ty. So good luck for your exams.
Yes. So mindset is, all I'm saying is that, look, I know a lot of you have been saying, what are we going to do for 21? But A, I can't really spill the beans yet, so I'll suggest you stick around, even through the other shows. Then I might spill the beans a bit later in the day. I just want to send a quick shout out to Love Shine and her buddy, Sir Shen. I think that's right. Stephanie, I want to say thanks for joining us on the page. And mindset is keep on posting, keep on talking to us, keep on using the page. And guys, this is where I then say, as Ty, thank you for joining us throughout the year. And don't you forget to use the page. But for now, we'll see you next time. Cheers.